Hello everyone. In this video we will be applying Bayes' theorem one more time. This time we'll be working with the more complicated formula, the total probability formula. Here's the problem we can work on. Karma has auto plants in Kentucky and Ohio. 25% of its 7,000 series models are made in Karma's Ohio plant, and the rest are made in its Kentucky plant. All of the 7,000s made in Ohio are two-door cars, while only 30% of the 7,000s made in Kentucky are two-door cars. The rest are four doors. If you see a two-door 7,000 series model on the street, what is the probability that it was made in Ohio? In other words, what is the probability that a 7,000 series model was made in Ohio, conditional on its being a two-door car? So let's run through those numbers one more time. So here's Kentucky and Ohio, where Karma has two plants. In the Ohio plant makes 25% of all of the 7,000 series cars. And all of the ones made in Ohio are two-door cars. The Kentucky plant makes 75% of all of the 7,000 series cars. 30% of them are two doors, but 70% of them are four doors. So here's our question. What is the probability that a 7,000 series model was made in Ohio, conditional on its being a two-door car? So this is the simplified form of Bayes' theorem. We've seen it before. It says that the probability of a hypothesis H given an item of evidence E equals the ratio on the right, the prior probability of the hypothesis times the probability of the evidence given the hypothesis divided by the total probability of the evidence. The probability of the evidence there in the denominator is relatively simple, but we can break that down as this weighted average. This is the total probability of E, or another way of thinking about it is the probability of E independent of the hypothesis. It says that the probability of E equals the probability of E given H weighted by the probability of H plus the probability of E given not H, weighted by the probability of not H. To apply this problem, we will use some abbreviations. We're going to let MIO stand for the statement that Karma 7,000 is made in Ohio. And we're going to let 2D stand for that Karma 7,000 is a two-door. And the question is, what is the probability of MIO, that should be an O, conditional on 2D? So what I'd like you to do is pause the video now and get a piece of paper and pencil, something to write with, and plug in those abbreviations, MIO and 2D, in this expression where you think they belong. Go ahead and hit pause now, and then when you're ready, unpause the video. So the question was, what's the probability that the car is made in Ohio conditional on its being a two-door car? If we look at the left-hand side of the equation, that is the conditional probability that we're after. Okay? It's the posterior probability of the hypothesis. The probability that a car is made in Ohio, given that it's a two-door car. Once we have the hypothesis and evidence correctly stated on the left-hand side of the equation, it's simply a matter of copying them into the right places on the right-hand side. So if our hypothesis is that the car is made in Ohio, it belongs up here on the upper left where we have the prior probability of the hypothesis. If the car being a two-door is the evidence, then that plugs in down here in the denominator where we have the total probability of the evidence. And then we always have the opposite conditional probability in the upper right, the probability that the car is a two-door given that it was made in Ohio. In other words, the probability of our evidence given our hypothesis. So here is the expression once again, the probability of MIO given 2D equals the probability of MIO times the probability of 2D given MIO divided by the probability of 2D. We're going to start plugging in values here in the right-hand side. Remember, the right-hand side of the equation carries our prior probabilities. These are probabilities that we already have. And two of them are fairly straightforward, those in the numerator. Why don't you hit pause on this video, or if you need to, back up a little bit to look at the story again, and see if you can determine what numbers, what numerical values go in those positions in this formulation. Go ahead and hit pause, and when you're ready, resume. So the prior probability of the claim that the car is made in Ohio is 25%. That's because 25% of Karma's 7000 series cars are made in Ohio. The rest are made in Kentucky. The probability that a car is a two-door car, given that it was made in Ohio, is 100%. All of Karma's Ohio-made cars, all of them are two-doors. So the probability that a 7000 series is a two-door, given that it was made in Ohio, is 100%. Now here's the real object of this video. We want to figure out the total probability of the evidence. So what is the probability, the total probability that a 7000 series car is a two-door? Well, here's that total probability formula once again. And as usual, it's stated in terms of E's and H's, evidence and hypothesis. However, if we uniformly plug in our abbreviations, we get this expression. The total probability that a car is a two-door equals the probability that it's a two-door given that it's made in Ohio, weighted by the probability that it was made in Ohio, plus the probability that the car is two-door given that it wasn't made in Ohio, weighted by the probability that it wasn't made in Ohio. I'd like you to go ahead and hit pause here once again and see if you can assign numerical values to all four of these terms on the right-hand side of the equation. Go ahead and hit pause and then resume when you're ready. So the first two terms after the equal sign are already available to us in the numerator. We already said that the prior probability that a Karma 7000 series is made in Ohio was 25%. And we already said that the probability that a car is a two-door, given that it was made in Ohio, is 100%. We need to examine then the other two terms that involve the car not being made in Ohio. The tilde means not. Well, if a car is not made in Ohio, then it was made in Kentucky. If a Karma 7000 series is not made in Ohio, then it's made in Kentucky. And so we know that term is 75%. Since 25% of the cars are made in Ohio, 75% of them are not made in Ohio. We also know that 30% of the cars made in Kentucky are two-doors. So the probability that a car is two-door, given that it was not made in Ohio, is 30%. From here, we can just multiply across. So 25% times 1 is 25%. And 30% times 75% is 22.5%, 0.225. When we add those together, we get the value 0.475. So what this tells us is that the total probability of the evidence statement, the total probability that the car is a two-door, is 47.5%. Another way of saying this is that 47.5% of Karma's 7000 series cars are two-doors. This is where we left off. We want to figure out the probability that the car is made in Ohio, given that it's a two-door. We already had the prior probability of the hypothesis, and we had the probability of the evidence given the hypothesis. And what we've done now is we've figured out what the total probability of the evidence is. So let's plug that in. So now that we have only numerical values on the right-hand side of the equation, it's time to do just a little bit of math. So 25% times 1 is 25%, and we need to divide that by 47.5%. The result is 52.6%, or a 0.526 probability. When I draw your attention, again, as always, to the relationship between the prior probability of the hypothesis, 25% of the cars on the road, the Karma's 7000 series cars on the road, were made in Ohio. But if you see that it was a two-door car, then you can be 52.6% confident that it was made in Ohio. So the fact that a car is a two-door car is some positive evidence that it was made in Ohio.